Welcome back to Graphics Addict. I'm Herb, and this video is going to introduce you to creating your own GL window without using or modifying code that we already have. So really truly creating your own window from scratch. And to do that, we're going to make a very simple window. The first thing I'm going to do that is I'm going to not load the game menu. Now, if you're making a game and you don't want any of the Appaloon stuff, or even if you just want to modify game menu and get rid of everything else, you can actually remove all of the files under game from the project, and then make sure that there's no references to them by building it and testing to see if the code compiles correctly. But once you've removed all of that, no big deal. You can just start fresh using only the framework. However, you might want to leave data structures and visuals there for a little bit and just replace some of these classes. For instance, the game menu, because you're going to need a game menu, right? I mean, ultimately, almost every game has one. But for today, I'm going to demonstrate just creating a new window. So we're going to go to game, right click, and we're going to do add new item. And we're going to double click on C++ class. So we're in here, we got to name it. We're going to call this MyFirstWindow. You can call it whatever you'd like. And the base class is GLWindow. That's GL capitals, L, and then a W capital, window. And everything else you should leave alone. That's all you have to do. Just click OK. It creates this file for you. Now, right off the bat, I got to let you know that we go to the CPP file for MyFirstWindow. In fact, let me just clear this up a little bit, sorry, by closing all of the windows except for MyFirstWindow, because we don't really need those open, so I'm going to close those. Yes, I did make a change to load, but let's bring load back. Let's go down to the bottom of load. And let's go ahead and do windows.add new MyFirstWindow. All right. And we're going to do hashtag include, and then in quotes, MyFirstWindow, which comes up. I hit return. It automatically populates. All right. Saving load now. So now we're tied to this, but we're not quite ready yet. We actually have to include GLWindow.h. And, it did do actually that for us. But I like to keep that separated. And I like that all on one line, and I like that on that line. It just makes it a little bit less lines to read through. And I'm actually going to delete these two, constructor, destructor. Don't need them, and we don't need anything to appear in the CPP file. What this does is it basically allows GLWindow's default constructor to run, and that's what we want. There are actually many different virtual functions, and if you go to definition on GLWindow and you locate that class and you go through it, you can see a list of all these virtual functions, and you can actually override all of these virtual functions if needed to change the way that a window works. And one of the earliest ones is init, and then onload, and then setup. Now and then customize. These four virtual functions can be overridden. Generally, I use onload. That way I save init in case I need to put something before onload and make it distinctly different than onload. But generally, if you look through this source code, you're going to find GL windows, and almost every one of them starts with an onload. Now, if you're familiar with processing, you might want to use setup. But, and that's why there is a setup, because I had learned processing quite deeply in 2003, and I structured a lot of this based on processing. But onload is fine. You're also going to want to usually override render, and you're going to want to override between. So So there you go. Let's go ahead and do that. So we go to my first window and we're going to go to void onload. Okay. We're just going to create the empty functions that we know we're going to populate. Between and render. So what is between for? Well, you can do your UI in between. Really anything other than drawing should be occurring in between. Although you could do all of this in render, it's better to do it in between. Between is called at a different time in the cycle, and so all of the windows have their between called at in the same list, and render is in a different list. So if one window is going to leave a situation for the next window, it's harder to debug if it's not all separated. So you want to keep your display in render, and your between is going to be all of the between calculations. And in fact, many of the framework's parts have between and render calls, and you can build off of those and then call them in the between and render of a GL window, for example. Now there's some things you can do in onload. One of them is you can, if you do this arrow, you can see all of the different calls that are possible and all of the different variables and values that you can manipulate in a window. But one of them is anchor. And what anchor does is it allows you to tell the window how big it is on the screen. So if you only wanted it to be half the screen, you would do 0.25, 0.25, 0.25, 0.25. And that would make it in the middle, but only half the screen's size. Now these windows don't have title bars, they don't have scroll bars, they're just sections that are scissored out, if you will, that are cut out, and in that is your window. And it even can bleed over outside of it, but generally you're just setting up a section of the screen that you're going to say, this is that window. So in this case, we actually want it to be full screen. So instead of anchor, I'm just going to type full screen. Okay. And you'll see that when it populates full screen over here in the autocomplete, it does say that that is a GL window call. There are these other calls that are full screen, but they have nothing to do with GL window. So just be aware of that. So full screen will just say, hey, I want this window to be the entire screen. Now, we want to change the background of the window because by default it's actually clear. And if no windows are on the screen, then you'll see an orange screen, distinct from the blue screen of Windows. The orange screen is the background of the entire application, and generally you want to cover up that orange screen. So we're going to do background dot pick. So what this is we're interacting with the crayon class, which is our color manipulation class. And background is a crayon that is a part of every GL window that determines its background. And if I were to say background pick clear, that would make it transparent. You can see that it's part of an enumerator called colors, and colors contains a whole bunch of codes that just tell crayon to pick that color out of the RGB color palette. And if I were to right click on clear and go to definition, you'll see that I wind up in a place where there are all these different colors that you can pick from, including some very special ones like the ANSI terminal colors, as well as generated stuff. I mean, this is just a huge list. And if you wanted to, you could also write in here, type capital C colors, colon, and now you can just pick one from the list as well. So you have a lot of options here. Let's go with black because we're trying to cover up but have a black screen. Now, we should probably do some sort of little animation. I think that that would help make the window more interesting. And so while it's not too complicated, we're just going to do something fun like a star field or something. So let's do Z indexed, and then we're going to have in there a Cartesian. A Cartesian is basically a 2.5 dimensional point. And we're going to call those stars, all right? And Z-index stars creates a sort of like a vector, but it doesn't use the vector terminology. It uses its own. So we're going to do stars. So in onload, we're going to have a little section, stars dot, well, we could even actually create a separate one for it, so void setup, okay? So we're now piggybacking off the virtual void setup to keep it separate and distinct from the Windows onload properties. And in fact, we could even call this init. So we'll call it init. Now we're going to go down to setup, and we're going to create the stars here. So stars, and in fact, I like to do this sometimes, and other times I don't. I'm going to move stars down to setup because it's really relevant after this point in the file. So stars dot length, stars dot size, and then we're going to make it, let's say 500 stars. That's a lot of stars, but we're just going to do that. Now we've got to go through the list. So we're going to do for in I equals 0, I is less than stars dot length, right? This sort of looks like Java. And then we're going to go in here and we're going to set the stars to random numbers, but we're going to use the size of the window so that it's responsive. So we're going to go stars dot set, stars I dot set, okay? And then we're going to set it to 3 integer values. So those integer values are going to be this width, this height, which is W and H. So that would put it all in the lower right-hand corner of the window. So instead, we're actually going to open this up, and we're going to convert it to a double. Okay. And we're going to multiply it by uniform, which is a very simple 0 to 1 random number uniform function. Okay. So this is going to create a whole bunch of stars that are just randomly displayed on the screen. And if we go down, they're not displayed yet, but the positions of the stars are selected. Now we're going to go down to render here, and we're going to actually copy this for loop. And we're going to remove this, okay? And we're going to add a little thing that's going to draw a rectangle for this. So we're going to type rectangle, open parenthesis. Now, the first thing that comes up, you'll notice, is that this is actually a Windows API call. However, if we type art dot, well, we have to include art. So let's include art. Include art.h. All right? So now if we type rectangle, we get a whole bunch of options. And one of them is color. And as I just explained, colors happen to be indexable by a number. So if we go to, again, the definition of black, we'll note that at 5, it becomes red. And from there on out, there's no special colors. But these first ones are special. Alabaster being white, cyan, chocolate, all of those things. So those, and then there's blues and purples and beiges. So let's just do this. We're going to go and go crayon, or colors. Okay, so what we're doing there is we're taking an integer, and we're going to call it integer I. And we're going to add 5 to it because that's the first non-special color. And what we're doing there is, and then we do crayons dot, not pick, but int. No, wait. Crayons dot, let's see. Oh, not crayons. Crayon. Wait a minute. Crayons dot. Oh, I know what we're doing wrong. So right here, we're going to do crayon color. All right, we'll call it pen. Or we'll call it ink, right? Crayon ink. Ink dot pick, and then pass that in. So what that's going to do is allow us, in fact, we can even make this a little more static by putting it out there. So what that did is it won't be recreated every time. Now it's going to be there whenever the window is created. So we've got ink, pick, color, 1 plus 5, rectangle, ink, and then what else do we want to pass in there? Well, we have to pass in 4 values. So those would be stars I dot x minus 1, stars I dot y plus 1, or y minus 1, stars I dot x plus 1 stars I dot y plus 1. So that's going to draw a tiny little box of 3 pixels in this rectangle, or as a rectangle in this window. So great. Now in the between, we're going to actually go through this list again. Now this is where inefficiency sort of shows up. We're going through the list twice here, and it would maybe be okay if we just did stars I dot x plus equals uniform times 2.0 and cast that to an int. You're going to find yourself casting a lot in this framework, but it's a necessary evil because we're using C++. So what this is going to do, minus, actually let's make this minus 1.5 there. What that will do is it will come up with a number between negative 1.5 and 1.5. And it's going to add that as an integer to x. So sometimes the stars won't move, and sometimes they will move, and it's going to be in a random way. But I said before, you can separate them. You don't have to separate them. You can do this kind of stuff here, or you can do it in the between, all right? But it's just a little less efficient. However, for this simple example, I'm going to break the rule. But you could or would or should maybe go over here and do that. That way you're not updating while rendering, because you've already determined the positions and then you render them in their positions. That's what's going on here. But because this is such... So I guess to discourage that from happening, I'm going to do it this way. It's better if you do it this way most of the time. But if you know what you're doing, you can get around it either way. But I like to keep them separate and distinct. So behavior goes under between. Render is for rendering. Init is for initialization of the window. Setup is being called automatically and is setting up our stars in random positions. So our window is done. We can add to it here. We could add like if input dot key down dx space. Okay, so now it's only going to move them when we hit the space bar. Input key down. So there's a little thing. When you have GLWindow, it's going to have a pointer to the input. That's so you don't have to include it. And that's so that it's just nicer. It keeps GLWindows separate from other implementations. But most of the time in processor and other places, you actually can put a dot here. But in the end, it's the same structure. So don't worry too much about that. Just use an arrow when you're in GLWindow for input, display, and audio. Actually, I don't think audio follows that. But anyway, for input, that's the way it works. So now whenever we hold down a space bar, it will jitter the stars. Okay? Let's just add a little bit more while we're at it. Else, okay? And then if input key down dx left, okay? Now we're looking at the left arrow key. So in this case, I'm going to take this for loop. All right. And I'm going to only subtract 1 from x. And that'll move it left. All right. So now that I have that, I'm just going to repeat that several times. And I'm going to do dx right, dx up, and dx down. And for right, we're going to add 1. And it should be just 1, not 1.0. For this, we're going to do -1 and then +1 for y. So down is plus. Weird. But it is. So that's done. So now I'm just going to build. All right. Now you'll notice up here there's these configurations and platforms. You'll note that the platform says Win32 and that I'm building a release. When I build a release, signed, unsigned. Oh, that doesn't matter. We'll just cast that to an int and that'll get rid of that problem. No big deal. Takes a little while to build it. Once it is done being built, we can then hit the play key. So I don't really recommend just hitting play, although you will eventually find yourself doing that. So if you just give us a moment, when the build's done, we'll check it out. Okay, that warning. If you see the warning E, unreferenced local variable, this actually only happens in release. And the reason why it's happening is because output in release is empty. Whereas in debug mode, there actually is a call there, and that's when it's using E. So you can ignore that one warning on audio 123. Okay, we've gone ahead and completed the build. It did take a little while. I would note that generally you're going to want to be in debug quiet divide by 0 warning. That's the one for debugging. Whereas when you're in release mode, or in release 2, or in production, production is really as optimal as it can be. And you have to test first release, then release 2, then production in order to make sure that everything's functioning in the proper way. But once you've gone through all of that, you can release, but you can release as release, or you can release under production. I know it's confusing, but production is the best way to release software, whereas release is just a good way of releasing software. And then debug, of course, is there for its own reasons. There's also release with full debug, release with debug symbols, release with optional logging. So full debug gives you as much debug as possible, but it's in release mode. Release with debug symbols only shows the symbols. This is good for tracking in a debugger. And you're going to need to use these as well to sort of build up to production. But ultimately, we're just building a release right now. We're going to hit play. And we should see the window show up in 1 second. Right. So this will happen to you. You will get a system error. And it will say it cannot find the DLL. What do you do? Well, you load up. You go into the Appleloon folder or the repo folder. You go into DLLs, 32-bit. You grab all of them. Oh, I noticed there's a couple here we don't want anymore. But anyway, you grab all these files, you copy them. You go out to the main folder and you locate the release or production or debug quiet by whatever. And you go into that folder and you paste it next to the executable. Now you've got a copy of all of those DLL files there. So it's going to complain about a bunch of these not being available to the executable. No big deal. We've now copied and pasted them. So I'm going to hit play again. And now it's working. Okay, now it's working. And now you can see that I am in the game we just made. And you'll notice that there are tiny little dots of all different colors all over the screen. And those are actually little tiny rectangles. Some of them you might actually be able to see that they are rectangles, whereas others are a little bit less obvious. And this is because we're using an integer value to display on something that can display on a double precision value. So if you change them, they would be slightly anti-alias, then you would see them. But this is basically what we're expecting. And remember, we created some commands in the between clause of the GL window. So let's go ahead and hit the space bar. And you'll see, maybe it's difficult, but they're wiggling, and they're wiggling around. And they're moving in random Brownian motion, doing random things, going to the left, going to the right. And if I let go of the space bar, they stop doing that. So that's working. Now, the green mouse cursor, which can be customized, is the default mouse cursor for the application. And if I hit the up arrow, they move up. And if I hit the left arrow, they move left. And if I hit down and right, they move in that direction. Pretty cool, huh? Now, if you keep going in one direction, you'll notice that they kind of disappear as they're being moved off the screen, because this is not panning an actual star field, but rather just moving a bunch of rectangles around. But it gives you an idea of how easy it is to create little graphical applications using this framework. Please sponsor us. me, so I can keep making these videos and describing other ways to use the framework and allow people to use this for research and just improve things in the graphical space. It's been a long time coming, 10 years and more of developing this little framework, and sadly, it needs more attention. It would be great. It would be a dream if you would sponsor us and contribute maybe source code back, or at least use it, star it, watch it on GitHub, and watch these videos because they're going to help you unlock the potential of this framework, which at first is very scary, I'm sure. Anyway, to get out of the application, Alt F4.